Today's lab for General Chemistry 2 is the acid-base titration, lab number 10. And what we're talking about here is ways of measuring the hydrogen ion concentration, the pH, the negative log, in two different acid situations, one being a strong acid and one being a not quite so strong acid. We would refer to it as a weak acid. Let's take a look at this pre-lab. Number 1 asks the question, what is the equivalence point? Well, you'll remember from our discussion about the hydrolysis of water that water naturally dissociates to give us hydronium ions, H3O plus, and hydroxide ions, OH minus, in equal proportion. And in another system that is in water, we could say that the equivalence point is where the hydronium ion and the hydroxide ion are present in equal measure, where their concentrations are the same. And remember that for water, that naturally occurs at a hydrogen ion concentration of 10 to the negative 7, or in other words, a pH of 7. Okay, question number 2 asks, what is the difference between a monoprotic acid and a polyprotic acid? Well, mono, of course, means one, and so a monoprotic acid we can think of as being able to donate one proton or hydrogen ion to an aqueous system. And polyprotic, of course, can donate more than one proton. Good examples for polyprotic would be things like H2SO4, sulfuric acid, or maybe phosphoric acid, H3PO4. The next question, what are the hazards that we're going to deal with in this lab? Well, obviously we have the strong acid of hydrochloric acid and the strong base of sodium hydroxide. The appropriate protection will be in place when we perform the experiment. And as always, if you should happen to get some of this on your hands, your arm, whatever, make sure and rinse it off quite thoroughly. If you get some on your gloves, we'll change gloves. The last question says, the equivalence point of the two titrations in this lab will be different. Can you explain why? Well, remember that strong acids, one of the ways we define a strong acid is that it can very fully dissociate. And weaker acids, like acetic acid, dissociate less. Let's come back to the picture just real quickly here, and let's get a representation of this. Once again, we have the equilibrium system for water, which will give us hydronium ions and hydroxide ions. Well, in the case of the strong acid hydrochloric acid, you'll see that that equivalence goes strongly towards the ions of hydrogen and chlorine ions. It very, very fully dissociates. Whereas acetic acid, although we still get plenty of hydrogen ions and the acetate ion, it's not as full. You'll notice that bottom arrow coming back to the reactants side a little bit less than with the strong acid of HCl. Okay, let's take a break and set up our